I want to talk about prime numbers for a moment. Prime numbers, for those who do not know, are numbers that are only divisible by 1 and themselves. This is at least one way to define prime. Now, this prime property is really nice and can create some very powerful divisibility arguments. It is incredibly useful in branches of mathematics such as number theory and even branches such as abstract algebra. However, there are lots of numbers that are not prime. For these numbers, we throw out all the nice prime properties. All is not lost though. There are times when we can inherit some prime properties for non-prime numbers. This happens when numbers are relatively prime. Relatively prime means that two or more numbers share no common factors. When two numbers are relatively prime, we inherit some powerful divisibility tools. One might ask, how can I tell when numbers are relatively prime? Well, I'm here to hopefully give at least some idea of how we can do this. Let's start with the simplest thought that I had. If we take an integer n, are n and n+1 relatively prime? My answer is yes, and here's why. Suppose that n and n+1 are not relatively prime. This means that there is an integer k that is a factor of both n and n+1, and k is greater than 1. Now, we can rewrite n to be some integer p times k, and we can rewrite n+1 to be some integer q times k. Adding 1 to n and 1 to p times k, we get that n+1 equals p times k plus 1, and n+1 equals q times k. We can now set these equal to each other and get pk plus 1 equals qk. We can now move over the pk to the other side and get 1 equals qk minus pk. Since k is a common factor for both p and q, we get that 1 equals q minus p. Since p, q, and k are all integers, this means that 1 equals an integer times an integer. This means that k and q minus p are equal to plus or minus 1, since these are the only possible solutions that we can have to an integer times an integer equals 1. Since k is greater than 1, we know that k is positive. This forces k to be equal to 1. This contradicts our initial hypothesis that k is greater than 1. Thus, we can conclude that n and n+1 are relatively prime. Therefore, we can use some prime properties for certain problems that contain n and n+1. I hope you enjoyed this video, and thanks for watching.